talk about density. Now, density is a really cool concept because it can be applied to almost any object. And it basically is defined as the mass of an object divided by its volume. Now, in shorthand form, that basically translates to D, which is density, is equal to mass over volume. And usually the corresponding units are grams, and volume units are milliliters. Although it can be any number of other units as an alternative. And what density tells you is basically how heavy or densely crowded something basically is in terms of its size. You know from personal experience, when you think of the word density, you think of the word dense. But if you were comparing maybe the density of a metal steel beam to water, you know that metal steel beam would be greatly much more concentrated or dense than that of water. So let's go ahead and dive in. First of all, before we even begin this, let's understand that the standard of density is probed from the basis of understanding that water, the gold standard, is generally accepted as 1.00 grams per milliliter. That is the density of water. Of course, for all intended purposes, this can be heavily influenced by or changed or altered slightly, depending on if the water is pure water, purely distilled, if it has ions in it, if it has something in it, if, I don't know, the temperature is hotter or colder. Those kind of parameters can definitely affect the density of water, but by and large, the density is understood to be 1.0 grams per milliliter for the density of water. And scientists kind of maximize on that understanding because if you know the density of water, you can compare that to other known compounds or elements on the periodic table. So with that being said, let's kind of dive into the concept of understanding what density significance is for you. Now, if you understand that density is equal to mass times volume, you rearranging that mathematically, you should also understand that the mass of that item is equal to the density times the volume. And of course, the cool thing about it is density is known as the derived unit. And derived units are units that are derived from that understanding of SI units. So from this actual density equation, which is a derived unit, you can actually derive more expressions to understand the relationship. You know that mass is equal to density times volume, but you also should be able to see that volume is equal to mass over the density. So those are the three relationships that you should know because they're very important in understanding how to determine how density affects things. Now, I throw that out there to ask you kind of general questions about the behaviors of certain liquids. It means that if you know the density of a liquid and you know the mass of it, or you know the volume, using two of the principles, you should be able to extract the third. So let's just use a practical example. All right. We know the density of water. We know that the density of water is 1.00 grams per milliliter. So that's the density of water. So if I ask ask you a question like, how many grams are in 55 milliliters of water? You should be able to tell me. And it's just manipulation. And even if you're not good at manipulating, you can kind of just plug and play. So we know that the basis of density is equal, D equals M over V. So, and the cool thing I like to do to help me remember density is kind of where the heart is. It's like with an arrow, and if you draw a line across it, you have an M on top and the V below it. So density is related to mass over volume. So I think that helps in terms of understanding it. That being said, we know that our density of water is 1.00 grams per milliliter. And we know that that's equal to some mass that we don't know. And we know the volume. The volume in this case is 55 milliliters. Now, if you're not an algebraic guru, you should understand that 55 must be multiplied by 1 to get your answer to this question. 55 here must be multiplied by that 1. And so to get your answer, it ends up being 55 grams. So that seems easy enough. I think it's easy enough to understand. So what if you have something where you don't know the density? Well, if you don't know the density, the cool thing is you can determine what the density is. And that's easily done, like almost a simple experiment or just kind of an investigation. The easiest way to find out the density of something is to find out how it displaces water. Now, let's say that we're given copper metal, and that copper metal is, 4.18 grams. Now, of course, if you're a scientist, you know that you can get the mass of copper by simply weighing it on a scale. If you have a 4.18 mass of copper, you can weigh that on a scale. Now, if you take that same copper and you put it in a graduated cylinder filled with water, it displaces that water, making it rise. And the subtraction of that difference can give you the volume. So let's say experimentally we were able to find a volume of, 3.14 mils. Sorry, excuse me. 3.14 mil. Well, density is nothing short other than the mass divided by the volume, and dividing that out, you would get your density. Divide them by 3.14, and we get 1.33 grams per milliliter. Now, it seems easy enough, and the only other difference or ability to do anything would be if you had to find one of the other variables. I've showed you how we can calculate volume. I've showed you how you can calculate density. The only one that hasn't been shown is mass, and the only difference would be just the 2 units given. But the arrangement is basically the same. So hopefully you understand